So I'm going to talk about oxidation numbers. So what are oxidation numbers? So now we're not going to talk about what are oxidation numbers. We're just going to look at how to figure out how to find oxidation numbers, right? So the first rule is an element by itself always has, or element by itself always have an oxidation number of 0. Let's see what that means. So let's say I have an element like, this is oxidation number you're talking about. So that's something like aluminum, the oxidation number is 0. Nitrogen, oxidation number is 0. Magnesium, oxidation number is 0. So elements by itself has oxidation number of 0. So rule number 2, monatomic ions. So what are monatomic ions? So when you think about it, a monatomic ion is when one atom forms an ion. Right, when it forms an ion, it has a plus or negative charge. For example, when calcium, and this K for potassium forms a charge when it bonds with something. It has a +1 charge, right? So this is a +1 ion, or sodium or magnesium forms a +2. The rule is the charge or the charge of a monatomic ion is the same as the oxidation number. So if potassium has a +1, because potassium is here, +1, that means that this is the atomic number, +1, then this is the atomic number would be 1 plus, this would be 3 minus 2 plus. That means the oxidation number has a charge of +1. If sodium has a charge, potassium's sodium, and nitrogen has a charge of -3. Nitrogen has a ionic charge of 3 minus, then it has the oxidation number of -3. Magnesium has a ionic charge of 2 plus, then it has an oxidation number of +2. So notice how the oxidation number is written as +1 and the ionic charge is written as 1 plus. So let's look at this rule here. The sum of the oxidation number for a neutral compound is equal to 0. So let's look at a neutral compound. Now usually they would give you the compound KCl and they ask you to find the oxidation number of this compound. Well, the sum of a neutral compound, that means the compound is, if the compound has no charge on it, that means it's a neutral compound. That means that the oxidation number is equal to 0. So what you do is you would find the oxidation number of each must be equal to 0. So let's say phosphorus, potassium potassium is 1 plus, right? Calcium is 1 minus. Calcium is 1 minus. So that means it has oxidation number of +1, oxidation number of -1. +1 minus 1 is equal to 0. So the oxidation number of calcium chloride is K +1, calcium -1. That will give you a charge of negative. So let's look at magnesium oxide. We want to find the oxidation number. So magnesium, we look at the table. Magnesium has a 2 plus charge, a ionic number of 2 plus. Oxygen would have a ionic charge. Oxygen would have a charge of 2 minus. So that means it has an oxidation number of a +2 has oxidation number of -2. 2 minus 2 will give you 0, so that means magnesium has oxidation number of +2 -2. And that would be the oxidation number of these both things. Let's look at this example. You have carbon of CO by itself, right? So you have CO, right? So you want to find what's the oxidation numbers of CO. So we look at the table. We see that oxygen is -2, and see that now we don't know what carbon is, but we don't know what the charge of carbon is. Carbon could be different. This means that could be different. It could be 1, it could be 2. So here's the thing. It says, because we know that the sum of the oxidation number for a neutral compound, this was a neutral compound, there was no charge, then a sum of the oxidation number for a neutral compound equals 0. So that means that if this is -2, for this to be neutral, this C must be +2, must have a charge of 2 minus then. So this has charge of -2. So that's oxidation of 2 minus oxygen -2. So if this has a charge of -2, this has oxygen of +2. And these two charges would cancel. So that means that the oxidation number for this would be C +2 oxygen -2. That's the oxidation numbers for this. Okay, let's look at this one. This one is a hard one. Nitrogen, NH3, right? Now, what is the ionic charge of nitrogen? Well, the thing is, the ionic charge is the same as the, let's say the monoatomic, same as the ionic charge, the monatomic ions, same as is the same as the ionic charge. These only work for group 1 and group 2 and group 7. It doesn't work for these groups. It doesn't actually work. It only works for group 1, 2 and group 7. It doesn't work for these groups here. Right? So that means if we have nitrogen, here, which is in this group here, we don't know what the charges are, right? So we look at the charges of the ones we do have. So we know hydrogen is usually a +1, right? Usually +1, so that's a rule. Hydrogen is 1+, so hydrogen is usually +1. That's easy to remember it too. So hydrogen forms a charge of 1+, so the oxidation number is +1. Now we have 3 hydrogens, so that's 3 is 3, so you multiply that by 3, so you get a +3 oxidation number. Now if this was a neutral, this is a neutral compound because there's no charge at the end, just 3 hydrogen, 1 nitrogen, so this must be 3 minus in order for it to be, this charge must be 3 minus in order for this to equal to 0. So this has an oxidation number of -3. We know this one to be 1+ from the table. The table states that monatomic ions, hydrogen is usually 1+ and 1- for metals. For non-metals is usually plus 1 for hydrogen. With metals is usually minus 1. So if we look at this one, Ca, C2, we want to assign oxidation numbers for this. Then we look at the table. We look at Ca. Well, we know Ca is here, so we know Ca plus 2 is 2 plus, so the oxidation number is plus 2. So the charge number is 2 plus, then the oxidation number is plus 2. The oxidation number with C, oxidation of C. Well, oxidation number is here, so we don't know what C is. We didn't even know what charge it is, what ionic charge it would form. So we don't know what C is. But since this is a neutral compound, then since this is a neutral compound, then the charge on this compound must be equal to, the oxidation number must be equal to 0. That's the rules. The sum of oxidation number for a neutral compound equals 0. So the sum of the oxidation number of this side must be equal 0. So this must be 2 minus, right? Wait, so the oxidation number, but here's the thing. There's two carbons. So in order to find what the oxidation number for each carbon is you would have to divide by 2, because it's 2. So you get negative 1. So the oxidation number is negative 1. See what we did? Each one is 2. So the oxidation number for each one would be negative 1. Look at this one here. This one we found the oxidation number to be 1, right? But there's 3, so we just say 3. So this, in order for this to balance, this must be 3 because this is 1, right? And then we assign 1 oxidation number to each. So if this is 3 hydrogen, the oxidation number on each would be 1. Here this is 1 hydrogen, so the oxidation number has to be negative 3. Be very careful. The oxidation number of this hydrogen is not plus 3. The oxidation number is actually plus 1 for each. So oxidation number here is minus 2, but because there's 2, you'd have to divide by 2, so the oxidation number is minus 1. So let's take a look at this one. Find the oxidation number of NO2. But this one is different. This one has a charge on it. Sometimes you're given a compound that is just NO2. That's a neutral compound. When you have a compound that says negative on it, that means it's a compound, but it also has a charge. So that's possible to have a compound that has a charge. So what do you do to find the oxidation number when the compound has a charge? So the rules are the sum of oxidation number for a polyatomic ion is equal to the ion charge. So the sum of the oxidation number for a polyatomic ion is equal to the ionic charge. So the sum of the two oxidation numbers would equal to the ionic charge. So what's the ionic charge of this one? It would be negative. Well, it's 1 negative. In this case, 1 negative is the ionic charge. So let's see now. Oxygen has a polyatomic number, has an ionic number of 2 minus, so it has a polyatomic number of minus. Does it work? Well, the rule states that, well, first of all, oxygen is negative, is in this column here. Oxygen, right? Oxygen it's not in 1 and 2 where you could use the rule. Well, what is the rules is, another rule is that in oxygen is usually, the oxidation number for oxygen is usually negative 2 and negative 1 for peroxide. So you could use oxygen as well. in this group. So the oxidation number for oxygen, the polyatomic number for oxygen is -2. -2. But we have 2 oxygen. So in reality, you have oxidation number. You have you have 2 oxygen, so 2 by 2. -2 by 2 would give you -4. So the oxidation number is -4 in total for oxygen. Remember, you have to multiply by -4 because you want to neutralize the charge. What I'd be to be equal to a certain number. So you find 2 oxygen. You find the 2 oxygen because you want to calculate this 2 is for 1. But here you just find the 2. So this is -2. So this is negative. The oxidation number is -2. But you have to multiply it by 2 because you want to be able to calculate both to see if how them to get them to be equal to -1. This -1 is equal to the oxidation number of -1. This is the oxygen number for a point ion is equal to the ionic charge. So the ionic charge is -1. The polyatomic number is the ionic charge is 1 minus the polyatomic number. The oxygen number will be -1. They both be equal. So now nitrogen. Now what the thing is, for this nitrogen, we know that the oxidation number for oxygen would be -4. So what would give us -1 for nitrogen? Because the nitrogen is in group. Anyway, you can't even take it because nitrogen is in this group. So what oxidation number would give us -1 when you have -4? Well, and we would have +3. +3, oxidation number of +3 minus the oxidation number of -4 would give us -1, because it's the sum of the oxidation number. That's the key word here. That's why I get mixed up. The sum of the oxidation numbers. So the key, so important word here is the sum of the oxidation number, not just the oxidation number. The sum of the oxidation number, which is 2. The oxidation number is -2, but the sum is -4. So the sum would be -4. So +3 minus 4 is equal to, and the sum also means these two things here. The sum of the oxidation numbers, which is 1, 2, which is this and this, +3 -4 is -1. So that means the oxidation number is +3 for oxygen be -2. And it's only right by the compound it was. So let's look at this one, HNO3. So we want to find the oxidation numbers of all. So we know hydrogen is in group 1. We know nitrogen is in group. Nitrogen is over here. We don't know what nitrogen is because nitrogen. Remember, this rule doesn't apply for these elements except oxygen, which is -2. These it doesn't apply, so we can't use the rule for nitrogen. So we know hydrogen was going to be has a oxidation number of +1. We know that oxygen, where's oxygen? Well, we know oxygen is -2. So oxidation number for oxygen would be -2. But there's 3 oxygens, so multiply that by 3. So you get the total number of -2 3s are 6. -6. Remember, this is a neutral compound. So the rules is for monatomic ions, same as this. The sum of the oxidation number for a neutral compound is equal to 0. So the sum of the oxidation number. So the sum of the oxidation, which is 1 minus 6 equals 0. So what number would give us like, say, +5? 1 plus 1 plus 5 is plus 6 minus 6 is 0. So that means oxidation number for nitrogen is plus 5. The oxidation number for oxygen is negative 6, but there's 3 of it. So it's actually 2 for each one. So H plus 1 nitrogen plus 5 oxygen minus 2.